get started. All right, so today we're doing day 5 of Unit 2, a slope review. So in my notes, I'm going to go to day 5. Remember, your slope is your rate of change. So you're changing your y or you're changing your x. When you're looking at it on a graph, you can look at the rise over the run. And then to do it with coordinates, you subtract your y's and subtract your x's. It's important that you stay consistent. The y and the x that come first need to come from the same point. The y and the x that come second need to come from the same point. It doesn't matter which one you call point 1 and which one you call point 2, as long as you stay consistent. There are 4 types of slope. When we're looking at a graph and we want to describe the slope, we look at whether it goes uphill, if it goes downhill, if it's horizontal, or if it's vertical. So when I look at this one, what does it do? Uphill. It goes uphill. And we know that because we always travel on a graph from left to right. So from left to right, I can see this is going uphill. Okay, which means it's going to have a positive slope. Okay. The next one, going from left to right, is going downhill. And really, you should, on a line, you'd have arrows on both ends. I'm just trying to see what direction we're going, right? So this one goes downhill. So we know that this one is going to be negative. All right, on the next one, this one is not steep at all. It's flat. This line right here from left to right, it's not uphill or downhill. It's, what do we call this one? Horizontal. To describe it, we describe it as horizontal. What type of slope does it have? It does have a slope. It has a slope of 0. There's a difference between not having a slope at all and having a slope of 0. 0 is a real number. The number 0 exists. That's a real slope. Okay? In this case, we can see we are allowed to run. We cannot rise. Right? We can run. We cannot rise. So that means my rise is a 0. So it's 0 over some number. You can put that in your calculator. 0 divided by whatever is going to be 0. Right? If I have $0 and I divide it amongst all of us in this class, we're all going to get 0. Okay? All right, when I look at the next one, oh, sorry. I know that green is hard to see. Horizontal, 0. We can run. We cannot rise. On the next one, we can rise, but we can't run. Mm-hmm. So this time we are vertical. Which means, what is my type of slope? Undefined. And if you ever get 0 and undefined confused and you're not sure which one to use when, you can put it in your calculator. Because if I take a calculator and I calculate my slope to be, let's say, I'm going to do it as a rise over a run. So I'm going to say 0 over 15. I know that's going to be a horizontal line because 0 is my rise. I'm not rising. I'm only running 15, right? So it's horizontal. My slope is 0. If I can rise, but I can't run, if I do 15 divided by 0, I can't run, then my calculator tells me that's the one that's undefined. Yeah, okay? In algebra, it would come up with a big screen. On the other type of calculator we would use, it would come up on the big screen and it would say error. And it would tell you the error is that it's undefined. Right? So it would tell you, every calculator in the world tells you this does not work. Okay? This is the one that if you want to call something a no slope, this is where you could say no slope. Because it's not a number. There's no slope. It's straight up. Okay? Questions on the types of slopes? Okay. Then, let's look at finding slope. We'll do a few of them together, and then I'll let you to do a couple on your own. So, remember, we are going to, if we don't have graph paper and we don't have the ability to graph it, we need to calculate the rise over the run by doing y2 minus y1 over x2 minus x1. It doesn't matter which one is your xy, your x1, y1, and which one's your x2, y2, as long as you stay consistent. When I'm given 2 points, I generally say the first one is x1, y1, and the second one is x2, y2. Okay? So my slope, we use the letter M for slope, is a fraction where I'm going to be subtracting on the top and I'm going to be subtracting on the bottom. What two numbers am I subtracting on the top? y2 minus y1, which is negative 4 and 7. On the bottom, what are the two numbers? Negative 6 and negative 4. Negative 6. Now I already have a minus there. Do I have to put the negative for the negative 4?
Yes.
Yes. So on the top, negative 4 minus 7 is negative, let's go with 11. And then on the bottom, negative 6 minus a negative 4 is really negative 6 plus 4, negative 2. What happens with two negatives? They make a positive, and then you reduce 11 over 2, which doesn't reduce, so we say add 11 over 2. This is my slope. Find the slope, we did it. Then describe the line. Is this uphill, downhill, horizontal, or vertical?
Uphill.
Uphill. Okay, and we knew that because it was a positive slope. All right, number 2, 28 and 9, 16. So my slope for number 2, fraction minus minus. What two numbers am I going to put in the numerator?
16 and 8.
16 and 8. You always start with the y's. Start with y. Y's on top. 16 and 8, because second one minus the first one. If you do the first one minus the second one, that's actually not going to be wrong as long as when you go to the denominator, you also do the first one minus the second one. Because that means you're calling this one 0.2 and this one 0.1, which is fine. You'll still get the same answer. Okay? If I do 16 and 8 on the top, what goes on the bottom? 9 and 20. 16 minus 8 is? 9 minus 20 is? Negative 11. When we write our answer, we never leave a negative in the denominator. What we do with it, if you have a negative in the denominator, when you reduce, it either moves out in front of the whole fraction, so like negative 8 over 11, or you just make it float up to the top because it's super tiny and light because it's negative. So it floats up to the top and you can put on the top negative 8 over 11. Wherever you want to put that negative, either out in front or with the 8, but it doesn't stay with the 11. Okay? So we can do negative out in front, 8 over 11, or you can put it up with the 8. You can write it negative 8 over 11. Both of those are the same thing. 8 over 11 doesn't reduce, so we leave it just like that. That's the slope. Describe it. Downhill. Does anybody want to come up and do number 3? Nobody? Okay, come on up. Pick whichever color you want to use. Okay.
Okay. So first, you want to label. This is X1. This is Y1.
Be a good audience.
This is X2, and this is Y2. Put N equals this. So
Can you slide it up just a little bit so you can see? Other way. There you go.
So we're going to plug in the Y2, which is 8. And we're going to plug in the Y1, which is -13. And then we're going to plug in the X2, which is 17. And then plug in the X1, which is 17 as well. So 8 minus -13, we add that together. So what is that? 21.
Very good.
And then 17 minus 17 is 0. So 21, what is 21 divided by 0?
Can we divide 21 by 0? Undefined. Very good. So then what's our graph going to look like? Vertical. Very good. Yes, please. Thank you. All right, so now just a couple of things. So we know it's undefined, we know it's vertical. If you put 21 over 0 as your answer on an assignment or a quiz or a worksheet, then you'll get points taken off because this isn't technically reduced. It reduces to an undefined fraction. Okay? So don't leave it as 21 over 0. Make sure you let us know that it is undefined. Okay? Let's look at the next one. The slope on the next one. What am I going to divide on the top? Or what am I going to subtract on the top? What two numbers?
Y2 and Y1.
Y2 and Y1, which are? 3 and 3. What am I going to put on the bottom?
20 and 19.
20 and 19. 3 minus 3?
0.
0. 20 minus 19?
1.
0 over 1 reduces to?
0.
Is it 0 or undefined? I've heard of both.
0.
0. Again, if you're not sure, you can type them in your calculator. So this one is 0 for my slope, which means what does this one look like?
Horizontal.
This one is horizontal. Okay. Does anybody want to do 5? Okay, come on up.
So we're going to identify our x1 and y1, and then we're going to identify the x2 and y2, and then we're going to find our slope. So fraction, and then a minus, minus, and then y2 and y1 go up here, so -15 minus 0. And then x2 and x1 go down here, so -11 minus 3. So -15 minus 0 is -15. And then -11 minus 3 is -14. So 2 negatives make a positive. So we just write 15 over 14. And this would be a positive slope, so it would be uphill.
Very good, thank you. Does anybody want to do 6? Anybody? No? Okay. right, let's look at number 6, my slope. What's going to go in the numerator? 10. Negative 2. I already have a minus, so I have to put the negative? Yes, I do. What's going to go in the denominator? And 19. 10 minus a negative 2 is really 10 plus 2, so 12. Negative 11 minus 19, negative 30. My negative is going to float out into the front or float up to the top. Oops, I forgot my 0. Can I reduce 12 over 30?
Yeah.
What does it reduce to?
2/5.
2/5. 6 goes into both of them. 6 goes into 12 2 times. And then 6 goes into 30 5 times. If you're like, reducing fractions, I hate reducing fractions. Again, these calculators are really smart. As long as the user puts the right thing, it gives you the right answer. 12 divided by 30 is 2/5. It does the reducing for you. Okay? Same thing if I did 12 divided by negative 30. It would know to move that negative to the top. Okay? Alright. So handy dandy. What does this look like when I describe it? Downhill. Alright. So now a little bit of a review of 2 concepts from algebra. I'm going to open this up so we can see it all better. Parallel lines. If you think about parallel lines, when we graph them, if I have 2 parallel lines and I graph them, one here and one here, I just made them both positive. Okay? What are we going to know about their slopes? They're going to be the same because they're going to have the same rise over run as each other. Right? So same rise over run, which means their slopes are the same. So they will have equal slopes or the same slopes. Perpendicular lines, what does it mean to be perpendicular?
They intersect each other at a 90-degree angle.
At a 90-degree angle. So I heard a couple people who just said they intersect each other. But we can't just go with they intersect each other, because if I look at an example and I look at these 2 lines, these 2 lines are not parallel or not perpendicular. Okay? Because this angle here is not 90. These 2 lines are perpendicular. Okay? So perpendicular intersects at 90. Oops. I wrote too big. Okay? Perpendicular lines intersect at 90. And when you look at the slopes, they're going to be opposite. And then they're going to be reciprocals. Do you know what I mean when I say opposites?
One's negative, one's positive.
One's negative, one's positive. They're going to have opposite signs. So you're going to have one of each sign, a positive one and a negative one. And then do you know what it means to be reciprocal? I'll give you a hint. 2/3 and 3/2 are reciprocals of each other.
Different fractions.
The same amount switched.
2/3 and 3/2 are reciprocals.
Oh, they're
They're flipped over. Your numerator and your denominator switch places. They're flipped over. Okay, so if you didn't know that, which most of us didn't, you might want to write it down. Flipped. It's super important that you remember it has to do both of these. It has to have opposite signs and it has to be flipped. It can't just be opposite. You can't have a -2 and a +4. Those are just opposites, but they're not also reciprocals. Okay? It can't be reciprocals and not opposite. If I look at these 2 numbers, they're reciprocals, but they're not opposite. So if I were to graph these two, they would not intersect at 90 degrees. Okay? Any line that intersects at an angle other than 90 is called, or are called, oblique. That's a new word for us. They didn't teach that in algebra. Oblique lines intersect but not at a 90-degree angle. Okay, so when I look here, these lines are oblique. Oops, you can't see it. Oblique. Okay? So anything that where it's not the same, because those are parallel, it's not opposite and reciprocal, it's perpendicular. Every other case is oblique. Okay? Every other case is oblique. So let's look at this first example here. I need to find both slopes. So for line 1, I'm going to say slope 1 equals my fraction bar, my minus. What two numbers am I going to put on top? In what order?
5 and negative 1.
5 and negative 1. I do need to write the negative. What two numbers am I going to write in the bottom?
Negative 5 minus 10.
Negative 5 and 10. So on the top, 5 minus negative 1 is really 5 plus 1, so that is 6. And on the bottom, negative 5 minus 10 is negative 15. Does this reduce? What goes into both 6 and 15? 3. So I'm going to move my negative to the top. 3 goes into 6 2 times, and 3 goes into 15 5 times. So my first slope is 2/5. My second slope, M2, the slope from line 2, equals minus. Okay? What am I going to put in the numerator?
Negative 8 and 7.
Negative 8 and 7. So if I started with negative 8, I have to start with negative 4 and then 2. Negative 8 minus 7. Negative 15. Negative 4 and negative 2.
Negative 6.
Negative over negative is
Positive.
positive. 15 over 6 reduces to
5 over 2.
yeah, because 3 goes into 15 5 times. 3 goes into 6 2 times. Are my two slopes the same? No, so we're not parallel. Are my two slopes opposites?
Yeah.
Yes, one's negative, one's positive. Are they also reciprocals? Yes, so they're opposites and they're reciprocals, which means these are perpendicular. Now, since we're studying math, remember we're all mathematicians because that's the definition of a mathematician is one who studies math. We are studying math, so we are mathematicians. Mathematicians like to abbreviate when we can. So if you don't want to write out the whole word perpendicular, do you remember what symbol you can use for perpendicular? The upside down capital T means perpendicular. Okay, let's look at the second one. Slope 1 equals, what's going to go in my numerator?
Negative 6 and 1.
Negative 6 and 1. What goes in my denominator?
5 and 3.
5 and 3. What's negative 6 minus 1? Negative 7. 5 minus 3? 2. Does that reduce? No, so that is what it is, right? All right, the next one, slope 2, minus. What goes in my numerator?
2 and negative 5.
2 and negative 5. What goes in my denominator? negative 1 and 1. 2 minus a negative 5. 7, because it's really 2 plus 5. Negative 1 minus 1?
Negative 2.
Negative 2. Be careful, it's a real common mistake to call that 0. When I see people put negative 1 minus 1, a lot of times y'all think that's 0. Or negative 4 minus 4, negative 7 minus 7. Because you just see the same number twice with a minus between it, and you tend to say that's 0. What do I need to do to simplify 7 over negative 2?
Put the negative on top.
Move the negative to the top. It kind of just floats on up there because it's so little. Are my slopes exactly the same?
Yeah.
So that means these lines are parallel. We haven't talked about the symbol for parallel because we haven't really looked at parallel lines too much this year. But the symbol is just two little parallel segments. Sometimes they're tilted a little to the right. Sometimes they're straight up and down depending on the textbook or the worksheet that you're looking at. Okay? When I do them in writing, I usually lean them a little bit so they don't look like one. Okay? All right, and then our last example, my slope 1 equals, what's going to go in the numerator?
3 and 1.
3 and 1. What's going to go in the denominator?
9 and 6.
9 and 6. 3 minus 1?
2.
9 minus 6?
3.
Can that reduce?
No.
Nope, so we're done there. My second line, 2. What's going to go in my numerator?
Negative 1 and 8.
Negative 1 and 8. What's going to go in my denominator?
Negative 2 and 4.
Negative 2 and 4. Negative 1 minus 8?
Negative 9.
Negative 9. Negative 2 minus 4?
Negative 6.
Negative 6. Negative over negative is positive. What goes into both 9 and 6?
3.
3. 3 goes into 9.
3 times.
3 times 3 goes into 6.
2 times.
2 times. So 3 halves for my slope 2. All right. These two lines, are they equal to each other? No. So they're not parallel. Are they opposites?
No.
No. So they can't be perpendicular. Even though they're reciprocals, they also have to be opposites to be perpendicular. So if they're not perpendicular and they're not parallel, then they are oblique. And I might make some of you very sad. There is no symbol for oblique. You just have to write it. Nope. At least as far as I've learned or seen, I've never seen a symbol for oblique. Okay? All right, so your assignment today is in Schoology. If you didn't do yesterday's, make sure you get that done today before it turns into a missing in the grade book.